Okay, finally in this very long section, we're going to talk about another way of looking at inverses of functions, the relationship between a function f and its function f inverse. And what I would recommend, since there's so much stuff in this section, is just go through it one piece at a time. Get the first piece done, maybe the stuff on the first video. Get that down, and then maybe go on to the next topic. Get that down, and get it down before you move on further, because otherwise it gets overwhelming. This section probably should have been 2 or 3 separate sections. So just make it that way for yourself. Break it into smaller pieces. And if you build up like that, you're going up steps of a ladder instead of like trying to jump to the rooftop or something. Okay, so the last thing here, we're finding the formula for f inverse from the formula for f. This is assuming you have formulas for functions, right? Not all functions have formulas, but if you do have a formula for f, what if we wanted to find the formula for f inverse, right? That's what this section is about. So it's an algorithm, and on this video, I'm just going to tell you what the algorithm is, and then I'll do examples on the next one. So first, you replace f of x with y. Why would we do that? Because y is a single symbol, whereas f of x is actually 4 things. And so it's easier to manipulate. We're going to manipulate the y, and in fact, it's going to end up in the middle of my equation somewhere, instead of alone by itself on one side. Okay, so we just change f of x to y. We just make up a letter for it. You could call it z or something if you want, but more common is y. Okay? And so I wrote that out just so you have it on the PDF in your notes. It's just to make it easier to manipulate. Okay? So then you switch x and y. Remember, doing the inverse, you're switching the first and second coordinate, which is the same thing if you're talking about formulas. It's the same thing as switching x and y, or your independent variable and your dependent variable, whatever they are. So here we're just using x and y. You just switch. So everywhere there's an x, you put a y, and everywhere there's a y, you put an x. There probably should be a y in only one place, though. But x you could have had in several places. This actually gives the inverse. It switches the first and second coordinates. So you could be a smart ass and just leave it there, but I don't recommend that because you'll get it wrong. Technically, you'd be right, though, if you just left it, but they usually give you more instructions. Okay? So I colored these to keep track of things because there's 2 different x's and there's 2 different y's because you just changed the original y into an x. And you change the original x into a y. So I'm going to keep the same color for the same number. So you'll see how that works. That's what this is saying down here. Right? Then you solve for y. This isn't the original y. It's the new y. It's the old x. You're solving for y. And why do we do that? Because we like having y alone on one side of the equation. And also, we didn't have a y in the original problem. We just had f of x equals something, some expression. F of x equals, say, x minus 3. And we want to write the answer without a y because there was no y in the original. And in fact, they're asking us to find the formula for f inverse. Where is it? There. Right? Find the formula for f inverse. Well, if I don't have f inverse in my answer, I haven't done it, have I? So you need to replace this y with f inverse of x. Right? That's another reason they're colored. So it's going to be f inverse of x. So you just do that. And so you'll have f inverse of x equals some expression in terms of x. But the x's down here used to be y's, and the y down here, or the f inverse down here of x used to be x. Okay, so if you're not quite following that, I'll do, hopefully you do. The idea is fairly simple, but I'll do an example on the next page. So I just re-explaining this. I don't like to read, when I write these things out, I don't like to just read what I wrote. I always found that boring as a student. So I state it, and then it'll be restated in print, right? Hopefully you've gotten used to that by now. Okay, let's do some examples.